Hello boys and girls, it's Mr. Malzberger with another fun little math lesson for you. Today we are going to talk about cylinders. Now a cylinder is the mathematical name for a shape like this, for like a can. We are going to find the surface area of a cylinder. We found volume of prisms before. You can find the volume of a cylinder as well. But we are going to look at the surface area, which is asking how much area does the outside surface of this cylinder take up. So when we look at it, we're going to see there is a circle on one side. There's a circle on the other side. So we have the area of two identical circles. They're going to have the exact same circumference, the exact same diameter, the exact same area. And then we have this wraparound part, the part that goes around the outside. What kind of shape do you really think that is? And what I want you to think about is this label right here. I'm not going to tear the whole label off because I want to know that this is tomato paste for later. But if I peeled off the label, it's two right angles right here, and it would go around and then stop right there. What shape is that? If I pull the label off, it's a rectangle, right? So to find the surface area of a cylinder, we're going to find the area of two identical circles. We know how to find the area of circles. And then we're going to find the area of this rectangle right here. Okay? So, surface area of cylinders. Let's remember that area in general is finding out how many squares of a certain size will fit on a two-dimensional shape. So if this is a 2 by 3 rectangle, you divide it up, you're going to say, oh, well, this is 6 squares, 1 by 1, let's say centimeter, squares will fit inside this 2 centimeter by 3 centimeter rectangle. We're finding out how many of these will fit in there. So we have to do that for the two circles, right? If you remember how to find the area of a circle, the formula is pi times the radius squared. It'd be a lot easier to find the area of a circle if the pi is our square. It's easier to find the area of a square than it is a circle, right? So remember, for pi, we're using 3.14. It goes on and on and on. If you forgot, the area of a circle, sorry, not the area, the circumference of a circle and its diameter is what created pi. Pi is how many times the diameter, the distance across the circle, will go around the outside of the circle. It goes around 3 full times, and there's this little piece. So there's starts right here, there's the first one, there's the second, and the third's like right here. And this gap right here makes a fraction. And it's when you turn the fraction into a decimal, it's 0.141592. It goes on forever and ever and ever. But we only use 3.14 for pi. Now the radius, if you forgot, the whole distance across is the diameter. And the radius is 1/2 the diameter, right? So if this if this diameter was 6, right, the whole way across, the radius would be 3 because it's half of 6, right? So the way to find the area of a circle is you're going to take pi, you're going to take the radius halfway across the circle, and you're going to square it. Remember, squaring means you're taking this number and you're multiplying it by itself. So these are the things you needed to remember. Now, you also need to learn how to draw a cylinder. It's kind of cool to be able to do. It's going to take a little while to get as good as mine, but mine aren't going to be perfect either, so don't worry about it. Instead of drawing a circle, we're going to draw an oval. And that's symmetrical as much as we possibly can. Mine's a little, it's not. Then we're going to draw 2 equal lines down the sides. Now, the trick is don't draw a straight line across, because that makes it look weird, because you have this curved dimension here, this depth, and if you draw a straight line, it looks weird. So what you're going to try and do is mimic this curve at the bottom as best you can, and that gives it kind of the, kind of looks like that a little bit. Okay, and so I'm only going to give you 3 different dimensions. I'm going to give you the height of the cylinder, and then I'm going to give you one of 2 other things. I'm either going to give you the diameter or the radius. But the radius is the one we need. That's the star of the show. We want the radius. So we want halfway. If I give you all the way, you got to make sure you cut it in half. It's the first thing I want you to do every time is check and see if you have the radius or you have the diameter, and make sure you label the radius. Okay? So let's create the formula. So we're going to have 2, there's the top and the bottom circles, right? So each circle is going to be pi times the radius squared. How many circles are there? There's 2 of them, so I'm going to put the 2 out in front. Now that rectangle, the wraparound part, we can know that it's the height tall, but how far is it? So when I lay it out, here's the height. But what's this distance? It's the distance around the circle, right? The outside of the circle, the outside of the can, the cylinder, is how long this rectangle is. So that's the circumference. Now circumference equals pi times the diameter. But I don't want to use the radius and the diameter. I would rather just use the radius. So what we're going to do is we're going to split this up into the radius version of the circumference formula, which is 2 times pi times the radius, because 2 radiuses equal 1 diameter. So we're not going to use this one. We're going to use these 2 together. So when we put these 2 together, we're going to get 2 pi's r squared, and then 2 pi r for the this distance here, times what? Times the height. So this is the 2 circles, and this is the rectangle. This is the formula. Now this formula looks, wow, really confusing, but if you break it down, it's not that bad. And I have a way to remember it. Of course, when you take the test, you have your notes. You can go back and watch this video again and get the formula there, and even watch me solve it. So memorizing it isn't that important at this point, but it's good to have your mind be able to remember things that are abstract and strange. So here is my mnemonic device. I turn all these symbols into a little sentence. You've heard me do it many times. So here we go. It's 2 pi's r square. So think of like the DiGiorno pizzas that come out in square. 2 pizza pies, right? 2 pies are square, and 2 pies are hot. Take 2 pizzas out of the oven, they're the square pies, and that is your surface area formula. And that looks like a bunch of stuff, but I'm going to make it simple, because realize there's only 2 different variables here. There's the r and the r, so these are going to be the same numbers, and then the h, which will be different. The 2 pi and the 2 pi are always there, and those are just numbers. So let's do a hypothetical one right here. Woo! I drew it that way, and I never do, and that's why I like the dotted one. Anyways, so I'm going to give you the radius this time. Okay, let's give the radius as 3 feet. And let's make the height, let's say 5 feet just for fun. All right, here's how you use this. You need the radius and you need the height. The radius is right here. This is the height, right? So we're going to plug it into the formula. So we're going to have 2 times pi times the radius, which is 3, right? And we're going to square it. So that's going to be 3 times 3 plus 2 pi, what's that radius? Oh, it's 3 times the height, right, which is 5. Now this still looks like a mess. You can put this directly into a calculator if you have one that you trust putting all this stuff into. You can do 2 times 3.14 times 3 squared, or you could put 9, plus 2 times 3.14 times 3 times 5. Now, I personally like to work it out a little bit farther so that I have kind of an idea of what the answer is going to be. I'll show you what I mean. Because if I just stick all this stuff into a calculator and I mess something up, how do I really know? Especially if my calculator doesn't let me see all of the things I input and some of it is off the screen. So here's what I do. I'm going to work these numbers down till I just have a number of pi's. Well, I know 2 times 3 is 9. I'm sorry, I said that wrong. I know that 3 squared is 3 times 3, which is 9. Right? I'm going to do this all the way down to one number. And 2 times 9 is 18. So I have 18 pi's, right? Does that make sense? I squared this. I have to do this first. I don't want to do 2 times 3 and get 6 and then square it, because then I'm going to get 36. And this is the correct number. So square it first, get the 9, double it, leave it. Now I'll do the other side. And you can do it all in one step if you want, or you can do 2. You could do 2 times 3 times 5. That's 6 times 5 is 30. I'm going to do it in 2 steps. 3 times 5 is 15, and 2 times 15 is 30. That leaves me with 30 pi. Now here's why I do it this way. I add this up. 18 plus 30 is 48 pi. Now I only have to do one multiplication in the calculator. I do 48 times 3.14. It's so much easier to get it correct. There's just, when you have to put the whole stream in, there's more likelihood you're going to make a mistake just pushing buttons if you can't see the whole screen. But the other thing is, I can kind of estimate. It's 3 times 48. Well, let's kind of round this up to make it even easier and make it 50. 3 times 50 means this is going to be somewhere around 150. So when I get my calculator, so here we go. I got my calculator, and I'm going to do 48. Oops, not on. There we go. 48 times 3.14. My answer is 150.72. Now, I could have put all of this in one big long line. But as you'll see, 2 times 3.14 times 3 squared plus 2 times 3.14. You see how on the screen stuff has already disappeared? I could get this right. It's not that hard. Times 5. I see I did it right. But I just kind of feel like this kind of, it just works better for me to work it out to here before I put it in the calculator. And this is also an acceptable answer in a lot of geometry. When you get to what is technically 10th grade geometry, and you can either get geometry in, well, now people get it in 8th, but 8th, 9th, or 10th grade, or your junior year, it depends. When you get there, you'll see that you can leave things in terms of pi, meaning this is how many times, this number times pi will get you the answer, because this is just an estimation. Because it's not really 3.14, it's 3.141592. It goes on forever, and so the number is going to be slightly bigger than 150, but this is close enough. Okay, let's do a couple more real quick. Okay, here you go. Draw with me. Make a oval. 2 lines down, and let's give you some dimensions here. Let's make this 10 inches, and let's make this 8 inches. Okay? All right, what I want you to do is I'd love for you to pause and try this. Just try it. And then start it up and see how you did. Okay, so hopefully you caught the first thing I did right here, which was I did not give you the radius. I gave you the diameter, correct? So if the diameter is 10, let's first find the radius. The radius is 5. So that formula, I'm going to write it up here. 2 pi's r square plus 2 pi's r hot. Okay, so my radius is 5 and my height is 8. Let me plug those all in. 2 pi, I've got 5 squared plus 2 pi, that's a really weird looking pi, and 5 times the height of 8. So you can also remember, once you get this first number in, it's 2 pi 5, 2 pi 5. So they're really close. It's just a squared and then the height right there. So I'm going to work this out. 5 squared is 5 times 5. 5 times 5 is 25, right? And if I have 2 quarters, that's 50 cents. So 25 times 2 is 50 pi. Yeah? And then over here, I see the 2 and the 5, and that makes me happy because 2 times 5 is what? It's 10. And that's an easy multiplication. 10 times 8 makes 80. So 80 pi. And now adding 50 and 80, I'm just going to add the 5 and the 8, and I get the 13. So it's really 130 times pi. Now I know 13 times 3 is 39. So this is going to be somewhere over, a little over 400. So 390, right? So somewhere around the 400 range when I multiply through. Let's check it out. So 130 times 3.14, I get 408.2. And ooh, I missed something. Hold on, back it up, all the way back to here. This is not the final answer. I forgot something very important. I did not put the tag at the end that says, oh, it's 150.72 what? Feet. And I have to put the square here because it's area. Whew, almost slipped on that one. And so this would be inches squared, right? So 408 little tiny 1 by 1 inch squares that fit all over this cylinder. Let's do one more, and then I'll give you a little practice sheet and we'll be done. Okay, I'm gonna make one that looks a little different and draw the oval on its side. These sometimes look weird too. I'm gonna make it a little bit longer. And same kind of thing, you make that curve and hope it looks as three-dimensional as possible. If you like the little dot there to make it look like you have the other side, you can do that. Find the center, right? Okay. 10 meters here. And then I'm going to make this 50 meters over here. Why not? Okay. Try this one. Pause it real quick. Try it out. You've got the formula right here. Go for it. Okay, here we go. I'm going to write the formula. Getting used to using formulas is a very valuable skill for preparation for geometry, but you use it in chemistry, you use it in physics, you use it in the sciences too. So sometimes kids say, why do I have to practice this? When am I ever going to use this in my real life? Well, in school, you're going to use it in a lot of different classes that use math, chemistry, and physics, and biology all use formulas. So practice plugging things in. It's a good skill to have. And also remembering the formula, because it just shows you that your brain can remember strange and random things. Okay, so here we go. First thing you need to check, did we get a diameter or a radius? We got the radius, so we're happy. So we're going to do 2 times pi times the radius, which was 10, squared. I'm going to basically copy that again. 2 pi 10. Instead of a square, I'm going to multiply it by the height right here, which is looks like a length that time. Okay, and now I'm going to simplify. I'm going to square this 10, and I know 10 times 10 is 100, correct? So 100 times 2 is 200 pies right there. I wonder how long it would take someone to eat 200 pies. Going to the other side, I've got 10 times 50 makes 500, right? 10 times 50, add one more zero, so 500. 500 times 2 is 1,000 pies. How long would it take someone to eat 1,000 pies? Well, let's put these two together. I get 1,200, or 1,200 pies. Okay. So again, I can estimate. I know 12 times 3 is 36, right? So 3,600 pi, something around that. It's going to be bigger than that, but around 3,600 would be a good estimate. And I can make sure my calculations are put into the calculator correctly. 3,768. Yep, bigger than 3,600, but around there. Then I got to put the measurement tag of meters and square it. Okay, so you know the formula. 2 pies are square and 2 pies are hot. Oops, that's upside down. Here you go with surface area cylinder practice. 3 in a row. Pause the video. Do all 3. If you really just want to go one at a time, you can. And then I'll go over them, and you should have these correct answers. This is the work you need to send to me for credit for this lesson. Okay, so pause the video. All right, here we are. Let's go over these 3 cylinders and find the surface area, the amount of little squares we can put on them. Yay, outside, 2 circles, and a wraparound rectangle. I'm going to remind myself of the formula. 2 pies are square and 2 pies are hot. DiGiorno, fresh from the oven. Or is it Red Bear in this square? I forget now. Okay, here we go. First thing I need to check is, do I have the radius or do I have the diameter? I have the radius, so check. I am good to go. We have the radius of 6. So I got 2 pi, the radius is 6 squared, plus 2 pi, the radius again, 6, times whatever the height is, which is 8 this time. Okay, I'm going to work this out. Some of my head math, I'll probably be faster than you. Of course, use a calculator for anything you want. Put it in any time you want. You can just do 2 times 3.14 times 6 squared plus 2 times 3.14 times 6 times 8. It'll give you the right answer. I like to work it out farther, as you know. Here we go. 6 times 6, which is 6 squared, is 36. I happen to know 36 times 2 is 72, because 30 twice is 60. 2 sixes makes 12. 60 and 12 is 70. 2 pies. Right here, I've got 6 times 8 is 48. I'm going to double that. 40 times 2 is 80. 8 times 2 is 16. 80 plus 16 is 96 pies. Okay, so I got to do 72 and 96. Well, the 2 makes it 98. I need 2 more from the 70 to make it 100. So 70 minus 2 is 168 times pi. So for my estimate now, I'm going to round that up to like 170. So 17 times 3, what is that? That's like 51. So around 500. Sounds good. Let's check it out. 168 times 3.14. 527.52 meters. That's your tag. And it's squared because it's area. Hope you got that one. Let's go on to number 2. Same thing. 2 pies are squared and 2 pies are hot. I was given the radius once again, so check, radius is 10. So 2 pi's, I've got a radius of 10, I'm going to square it, plus 2 pi's, 10 again, times whatever the other measurement is. This time is 20. Okay, so 10 squared is 10 times 10. That's 100 times 2. So 200 pi's right there. And then I've got 10 times 20 is 200. And 200 times 2 is 400. So 200 plus 400 is 600 pi. So 6 times 3 is about 18, so 1,800 is my ballpark estimation. Clear that up. 600 times 3.14 is 1884, 1,884. My units of measure is inches, and I'm going to square that. And finally, the last one. 2 pi's are square and 2 pi's are hot. Do you like pineapple on your pizza, or do you think that is the worst thing ever? I think there's two schools of thought. Either you love pineapple or you think it's gross. All right. I eat like pineapple. I eat pineapple all the time, so I'm a pineapple kid. Here we go. Let's figure this out. Checking here, I did not get the radius. I got the diameter, which is 6. So my radius is half of 6, and that's 3. Okay, so 2 pi, radius of 3 squared plus 2 pi, that's a 3 again, times what's my other number? 15. Okay, 3 squared is 3 times 3, that's 9. 9 times 2 is 18. So 18 pi. 3 times 15 is 30 and 15, that's 45. And 45 doubled is 80 plus, that's 10. 80 and 10 make 90. 90 pi. So 18 plus 90, that's 108 pi. So around like 324 to 325 would be my estimate. 108 times 3.14 is 339.12. I said 124, 125. That's just that. It's always above because of the 1.14. I'm just kind of giving myself a ballpark to know that I did it decently. Hopefully that makes sense to you. I hope you see that it is just, we're just plugging in this number, the radius, twice, and the height each time, and just doing the little commands. This is just plugging in formulas. Hopefully this makes sense to you. And yeah, look for homework number 4. All right? Talk to you next time. Take care.